The W is the shape of water. So W is water because it's shaped like water. And also M for mountain. So they were teaching children to look at the letter and relate it to an actual symbol, a hieroglyph of something, which when you think of water, you can remember the water shape. It's easy because it's just like water.
Alright folks, what I got here is a level P900. I've leveled it on both this x-axis and the y-axis. And what I'm going to do is I'm actually going to zoom out. And you're going to see that as I zoom out, the horizon rises and we're zooming into water. And as I zoom out more, the horizon raises even more, relative to the center of frame. And as I zoom out more, the horizon raises more and more and more, until the horizon's not even the frame anymore. And as I zoom back in, horizon lowers.
If you center a camera on an object, and then you just merely zoom in, what you find out is the center object you were centered on is no longer in the center. And the reason why is because of bending light.
If your visibility is diminished, then you can't see as far. So if there's upwards curvature, the further you can see, the horizon is going to be higher, the further you can see because it's curving upwards. So this camera itself has a level. And so you can see that when the camera is perfectly level and when it's not. I can also tilt it this way and that way and it'll tell me that my camera's not level. So we got a level camera on both axes and we're zooming into water. And I've proved that the camera's level. And we're still zooming into water.
It's the same with a ship that appears to be going over the horizon. It's not actually going over the horizon. With your naked eye, it appears as if a ship is going over a horizon. However, if you get your camera out and you zoom in on the ship's hull is still there and you can see the whole ship.
W. Water.
Stake 1 has the laser 30 centimeters above the water. Stake 2, he has the laser centered on that stake at 30 centimeters above the water. Then they sailed to the center between the two stakes, and they were going to measure how high the laser was above the water using another stake. Okay, so my friend sailed back to my position. Together we made a measurement in the middle of the distance between the two stakes. The measurement showed that the distance from the water surface to the beam was 39 to 40 centimeters. We decided to check if everything was okay with the laser and the stakes. Everything was still perfectly fine. We made another measurement in the middle and it showed the same thing as previously. The beam was about 40 centimeters above the water surface. So in other words, on both ends, the laser was 30 centimeters above the surface of the water on both shorelines. However, in the center, the laser was 40 centimeters above the water surface, which would indicate the water actually curved like this. So it actually showed that the lake had some sort of concavity to it of 10 centimeters in the center. So if you go 1 kilometer, you go down 10 centimeters in arc if you're having, two stakes at equal levels above the water. So the water actually goes down 10 centimeters in concavity. So I thought this is an interesting experiment. Anybody could do this experiment. And this guy was not even a believer in concave Earth at all, and now he is.
Yeah, that's what's happening on a big scale. There's a lot of air and it's lighter. So as you know, the heavier stuff's being pushed what we call down, which is just outwards. And so there's a ball of air inside the hydrosphere. So this is what your mainstream model is saying, that there's a sphere on the outside of the Earth of water. But it's not, it's on the inside, being pressed down and out by the atmosphere.